Ahena mamkela itinyiko machapkosa mamkelaka to the physical sciences lesson in namuntlha. We are looking at lesson number 36 and we are looking at description of motion, safety features in cars and graphs of motion. Okay, and like we always say, my grade 10 kufika grade 12 hinkwenu meamkela wini kuba mere part ya lesson day hikuba hinkwenu makeitariwa. So you don't go anywhere, you stay there, you're gonna enjoy it. There is always something for you from our lessons. Let's quickly look at the position versus time graph here. Now, position versus time graph, it's a graph that tells us about the position of an object at a given time. So that position can change, and when that change in position occurs, we have what we call displacement of the object. Hence, up here on the vertical axis, I have displacement delta x in meters and time in seconds along our horizontal axis there. Okay, and that is the way it should be all the time. When you draw graphs, make sure that your time is along the horizontal axis, and your other variable, which could either be displacement, velocity, acceleration, has to be on your vertical axis. The second thing that you must be wary of every time you draw a graph in physical sciences is to ensure that the quantity that you have placed in that axis, be it horizontal axis or vertical axis, with the horizontal axis we are sure it shall be time. Make sure you also show the unit in which that quantity is measured. In this case, time along the horizontal is measured in seconds, and therefore for that reason, I have in brackets, after writing time, in brackets I put S to say this time is measured in seconds. Along the vertical, I've got displacement, and I'm saying that this displacement is measured in meters. Don't make any mistake with this, because if you don't put in those units, you're going to lose marks in the exam. Okay, now if I have an object that is moving, okay, along some horizontal distance, and say that object started moving from time 0 and already it was at position 2 meters. After 1 second, I find it at 4 meters away from its initial position. After 2 seconds, I'm seeing it is at 6 meters. After 3 seconds, it's at 8 meters, and after 4 it is at 10, after 5 it is at 12. Okay, when I draw a line along those points that I have made there, I have now drawn a graph of position versus time. And from this position versus time, there are things that I can learn from it about the motion of this object. What are those things? One, if I look at this graph here, this is a graph of straight line. So this is a straight line graph. When I have a straight line graph, I can be able to find what we call the gradient. What is gradient? Going back to mathematics, if I've got a line graph, y and x, change in y over change in x, give me the gradient of that particular line. Okay, now in this case, along the vertical, I'm not having y, I've got x, I've got displacement. So displacement divided by time, let's see what we're going to get there. So gradient will be, in this case, will be equal to change in displacement, which is delta x, divided by change in time, which is in our mathematical relationships, which we are used to x and y, my delta t there would actually be the x values along the horizontal. Now let's work it out here. So gradient m equals, let me start using what we know already from mathematics. Change in y over change in x. Now what is this change in y here? Change in y is change in displacement. So it will be x2 minus x1 divided by t2 minus t1. This is change in displacement over change in time, if you like. So if I work that out, let me take any 2 points, because the formula pushes me to look for 2 points to be able to do this quickly. If I take this point and this point there, along my y, my x2 displacement, x position, say this is my position 2 and this is my position 1. Displacement at position 2 is 8. So I will say 8 minus, that's x2. x1 will be my displacement at this point, which is 4. You divide that. My t2 time at that point is what? It's 3. Minus my t1, that is time at this point, is what? It's 1 second. So I will have this as 8 minus 4, which is 4, divided by 3 minus 1, which is 2. And the answer here is what? 4. 4 divided by 2 gives you 2. And what do we see here? This is displacement in meters, and this is time in seconds. So the unit should be 2 meters per second. This tells us that the gradient of position versus time gives the velocity of the object. Very important for you to know that. Let's meet in the next section of this lesson.